just so everyone knows, and you should see a notification pop up. Really quickly, if anyone would like to have closed captioning today, Zoom has a really nice function for adding that. If you go to, on my screen, it was on the More button, and then you go to Live Transcript and enable auto transcription, and that'll have some live captioning at the bottom. And we'll also have closed captioning on the videos when they're eventually posted online to the YouTube account. Really quickly, just want to highlight the workshop organizers today, who are the EFISA co-chairs. So that includes Millie Chapman, who's at UC Berkeley, Dave Klingus at University of Florida, myself from Virginia Tech, and Alyssa Wilson from Notre Dame. A major thank you to all of our workshop contributors. There's a long list of those, but especially those who are contributing the tutorial workshops today that you'll see throughout the day, as well as those other members of EFI who have contributed presentations either about the challenge themes or the working groups within EFI, which we'll highlight tomorrow. And also, this is a really nice time to just highlight the fact that all of the workshop organizers and contributors are all early career individuals. And we think that that's a pretty cool contribution, that this has really been led kind of from the ground up. I'd also like to just say a quick thank you to the EFI Steering Committee for their support and consideration as we've been developing the workshop, especially Mike Dietz, Quinn Thomas, and Sophie Peters. We'd also like to highlight that today and tomorrow throughout the workshop, and really in all EFI activities, we will be following the EFI core values, which means that we expect all participants on the call to behave with respect at all times, and anyone who's engaging in sort of disrespectful or abusive conduct will be removed from the workshop immediately, although we hopefully don't anticipate that happening. And just importantly, as a reminder that as part of registering for the workshop, we did ask that you sort of read and consent to that code of conduct. I think there will be a document posted in the chat at some point, which is our sort of go-to resources list of content that might be helpful for both the workshop as well as other resources. And you'll find a link to that code of conduct if you're interested in reading more about that. And in the case that there is misconduct today, please don't hesitate to contact one of us co-chairs via the Zoom chat. So that's Millie, Dave, Alyssa, or myself. Or if you'd prefer to report that anonymously, you can do so via the misconduct reporting form that should be in that sort of go-to resources document. So now a little bit about the Ecological Forecasting Initiative, or EFI, as I've probably been referring to it so far. So EFI is a grassroots consortium which is aimed at building and supporting an interdisciplinary community of practice around iterative near-term ecological forecasts. Iterative forecasts are a really great tool for helping provide management decisions, as well as for testing foundational ecological theory and for applying the scientific method. There's lots of different types of forecasts, and we'll see some examples of those which are being supported through the NEON Forecasting Challenge, including terrestrial carbon or water fluxes, tick populations, beetle communities, canopy greenness, and water temperature and dissolved oxygen. Importantly, an ecological forecast is something that provides an estimate of a future state of an ecological system with uncertainty around that prediction. And so just like weather forecasts help us prepare for the future in our daily lives, ecological forecasts allow society to prepare for future changes in ecosystem services. We'd like to just remind everyone that anyone is welcome to join in EFI activities. Our membership ranges from those who have little to no experience in ecological forecasting to those who have labs and research programs specifically dedicated to creating and using forecasts. You'll find more forecast examples and ways to get involved with EFI on our website, which is ecoforecast.org, but you'll also hear lots more about that throughout today and tomorrow. A little bit about EFISA, as we like to call it. We were first founded coming out of EFI's first meeting, which happened back in person in DC in May of 2019. And since then, we've been meeting about monthly for a number of different activities, including journal discussions. We've had quite a few really interesting guest speakers join us. And the monthly meetings are really sort of driven by student involvement and interest. So it's really kind of driven by the needs of those joining the meetings. And our goal is to serve as an inclusive resource to help those of us who are learning ecological forecasting engage in the practice and sort of share resources and information among ourselves. A brief overview of what we're going to be doing today and tomorrow. Today is sort of focused on these skills-based workshops. We have five really exciting workshops that are focused on providing some tutorials and really useful information on how to directly contribute to the Neon Forecast Challenge, which you'll hear a lot about. But also these workshops are, aside from enabling participation in the challenge, will also teach some kind of fundamental resources for forecasting at large. And then tomorrow is going to be focused more on lots of sort of short form flash talks regarding participants in the forecast challenge, as well as FE activities such as our working groups, which you'll hear more about tomorrow, as well as sort of some brainstorming of networking and developing projects within the student group. We're going to be using Poll Everywhere today, like I mentioned earlier, to facilitate our Q&A sessions. So if everyone could go to the Poll Everywhere link, so it's going to be pollev.com/FE 2021, and you'll see this sort of welcome where you can kind of put in a username, although it won't be associated with your questions as we go throughout the day. So if everyone can go there, and then we've got sort of a kind of warm-up poll here. So if you go and click your image, it should show up on, or sorry, your location, it should show up on here. And this is really exciting to see. We've got some international folks joining us. So we've got quite a few time zones covered here between the US and Canada and Australia, kind of across the globe. So we'll give that maybe just a couple more minutes to let people click in. And like I said, we'll use this throughout the day to sort of to kind of gather questions. And if you haven't used Poll Everywhere before, there'll be sort of a thumbs up or thumbs down option for questions that are more question-based. And we'll use that sort of guide and prioritize our answering of questions. And let's see, so I think how do I go to the next slide now? So I think with that, I can say thank you to everyone for joining us today. I'll go ahead and stop sharing. And we'll sort of maybe save that map image so that we can kind of highlight that in the future. And if Quinn Thomas is on, I might pass it on over to him to give an introduction to sort of the Neon Forecast Challenge.
Great, thank you, Whitney. That was a great introduction to the meeting and to the Ecological Forecasting Initiative. I'm Quinn Thomas. I'm faculty at Virginia Tech. And then within the Ecological Forecasting Initiative, we have a National Science Foundation funded effort called Resource Coordination Network. And I'm the PI of that effort. And I'll be introducing that to you today, and one of the main thrusts of it, which is the forecasting challenge. First of all, I want to thank the organizers for organizing this student event. It's just incredible to see how many people are here. And I've had a lot of fun seeing the GitHub and the Slack channels as the organization, and just a lot of activity. And a lot of just the planning of this has resulted in many of the Resource Coordination Network goals that we have. So a huge thanks to you. And I'm just thrilled that this week or these few days are happening. So to get started, just welcome from the larger steering committee for the Resource Coordination Network. All of these folks have been are involved in the 5-year kind of trajectory of this project, where we're currently in year 2, and I'll explain more about that later. So decisions are being made in the context of a rapidly changing environment, and these all relate to things from algal blooms to, when do I want to go see the fall colors in Vermont? And we want to go from the left-hand side of here, which are hazy future, to the right-hand side where we can pick a path of the future that we want. And we hope that ecological forecasting can help guide that decision-making process. And so the overall goal is to basically predict weather like we can predict nature like we can predict the weather. And a lot of what we're doing is inspired by the growth of the weather forecasting community over the past decades. And I wanted to put a little context into what we sort of mean by near-term iterative forecasts. The idea of a forecast is a probabilistic out-of-sample prediction, meaning it's predicting data that was not used to construct a model or the framework for prediction. And in many cases, you might hear think about testing and training data sets or things like that. Well, the future is by default out-of-sample, and so that there's that's why the future is predicting the future is a really big focus of this near-term iterative forecasting. It's iterative in that the forecasts are repeated and can be evaluated with data so that future forecasts can reflect knowledge gained from that evaluation. And near-term means it's at the time scale that allows for evaluation, basically data decadal. An end-of-century forecast will be hard to evaluate. And so it's really focusing on that shorter term time scale. And just a very brief overview of kind of a very practical ecological kind of forecast. This is a project that I'm involved in, and others from Virginia Tech that are here, along with folks at Florida and NC State, and funded by the National Science Foundation, where we're collecting meteorology and stream data. We're also collecting data of temperature at a reservoir and other measures of water quality that get pushed up to GitHub, get moved, to the cloud so that others can access it, whereby that data is used as a model input to run a lake model that's used to make a prediction of today. There's data that comes in also from the reservoir that's used to update the model, using, in this case, the term is data assimilation, and a particular method is the ensemble common filter. So now this model made a prediction of today from yesterday to today that is then updated with data from today. So it's as consistent as possible with today, that then is used as initial conditions for a forecast 16 days in the future using NOAA weather as an input, where we get a 14-day forecast or a 16-day forecast, and then it gets translated to what the water resource managers want to see, because they don't want to see this figure. They want to see something that's a little bit more tailored to their decision-making process that's then emailed to them. And so, this kind of overview kind of highlights many of the aspects of ecological forecasting, from sensors to cyber infrastructure to modeling of where you need a lot of domain expertise, to thinking about interfacing with weather forecasts, to thinking about visualizations and decision support. So there's a lot of ways to be involved in ecological forecasting. That's what really excites us most about it. And so fundamentally, forecasting is a win-win. Basic science for rapid testing of quantitative hypotheses, particularly if you're predicting with different models that have different assumptions on how the world works, to actionable science, forecasts to support decisions. And so ultimately, what we need are more forecasts from a diversity of perspectives and approaches that engage more partners. And that will allow us to discover what is predictable in nature and what predictions are most beneficial for society. And so to this end, the Ecological Forecasting Initiative, which Whitney already introduced, kind of paired up with NEON. And NEON's the National Ecological Observatory Network that has terrestrial and freshwater data across the U.S., including Hawaii and Puerto Rico and Alaska, where they're basically collecting observational data of these ecosystems. And so how can we bring these two together to really galvanize the ecological forecasting community? And that has led to this research coordination network. which is a 5-year project to create a community of practice. And we're already doing that. The act of building this workshop and sharing of information is building the community of practice of sharing techniques, figuring out what works best. That builds the capacity for ecological forecasting by leveraging NEON data products. And the principal tool that we are excited about is really to really focus the effort is the NEON Ecological Forecasting Challenge. And what that is a formalized, meaning it has a set of protocols, a set of rules and standards, things like that, to develop and challenge you to develop near-term iterative forecasts of different NEON data products. And by a lot of folks doing that using different methods, different types of data, to discover how forecasts compare to each other and to observations. And I'll provide more details on this tomorrow. But this process of building the NEON Forecasting Challenge really has been a community effort. And that's another really exciting aspect of it. We had a meeting last May where over 200 people are engaged in kind of planning and thinking about what this forecasting challenge could be. We've had working groups, basically design teams, thinking about like, aquatics, terrestrial, what does a forecasting challenge look like in that domain? Cyber infrastructure, building out standards that you'll see a lot today, and partnerships and then we officially launched in 2020. And so over 200 people have been involved in planning. Over 50 teams have registered to submit. And there's been 3 graduate courses already taught based on the challenge. And so this idea of common forecast protocols across ecological systems and scales, you can see here the 5 themes. We have an aquatics theme with temperature and oxygen in both a lake and a stream, tick larval abundance, which represents our population theme, carbon and water fluxes from flux towers at sites that span a water availability gradient, beetle community richness, which represents our community ecology theme, and then phenology, both the timing of greenness and actually the timing of fall colors, which kind of represents an ecosystem level kind of theme as well. And so you'll learn more about these tomorrow, but the challenge is to contribute to challenge you to forecast these variables before NEON collects them. And so this challenge is basically a means to advance broader objectives. The community of forecasting needs protocols, standards, and best practices. It needs training opportunities to grow the field. It needs software and tools. It needs an engagement of federal agencies and other partners, and it needs to we need to develop a synthetic understanding of emergent patterns. What is more forecastable? What time horizons? Things like that, which will all emerge out of the process of building out and executing this forecasting challenge. And so, in the context of the overall resource coordination network, we're in year 2. Which is focused on year 1 was really focused on building out this challenge, getting community feedback, determining the standards and rules. And year 2 is really focused on synthesis and development of educational materials to empower new folks to engage. And that also includes inclusive pedagogy. And then part of somewhere between year 2 and 3 is early career forecasting tutorial, which is being represented and done really well by this group here. So we're in the middle of this resource coordination network, which means it'll be going on for a while. And so your engagement in this, will, persist. And we're really, really, really excited to have everybody here and welcome you. And, if you have any questions, you can always, I didn't put my email up here, but you can always contact me to learn more. And then the student group is really tuned in to. We have 2 members of the student group on the steering committee. So there's a lot of really close engagement with the early career folks within this project.